Well, hello. I had to apologize because I promised this video uh, about the beginning of the month, beginning of January, I could say. And I had some problems. My wife passed away December the 30th, and I couldn't get back out here. Neither I had the fortitude to do it, to be honest with you. And then I found out that the computer I had was no good because it lacked one of these plugs that's supposed to be for the printer port. See this plug out here? This is supposed to be for the printer port, and the newer computers don't have it. So I had to get one on eBay and rush it over so we can do the test. Now today, we're going to do the test for the first time, and I had this computer a couple of days ago, and I loaded up the Mach 3, that is MACH3. So since it's a totally free program, thank God, it's a totally free program. The program can be downloaded from the internet. The only thing the free version and the paid version has is that the free version is limited to 500 lines, and the paid version is unlimited for the number of lines. I don't know if it has a limit, but I've seen programs with 2,000 lines or more. But anyway, for what we need, there is nothing. There is perfect. 500 lines for us to run small CNC or to run these fans. That's what it is, a program for the CNC. To run these fans is no problem. The free program is supposed to be for amateurs and hobbyists. Here. We have one. So, I got the hardware, and I spent within all the whistles and bells and everything, I spent about $200 on it. The most expensive part was the circuitry. That was about $90 on eBay, brand new. And we have the breakout board and the 2 drivers. It came with 4 drivers actually, but I only need to hook up 2 because I only have 2 stepping motors. The stepping motors, I got them on eBay too, for $18 a piece, brand new. And then between the little pulleys and belts and whatnot, I must have spent another $30, something like that. They are extremely cheap. The drawer glides, I had them. In fact, some of them are resuscitated and recycled, and that's all. Now, the code that you write to run this program or to run your CNC perhaps, or this thing, it's what's called a G code. It's a program that lets you route. But it's extremely easy. You don't have to know machine language. None of the garbage of a Visual 1 and Visual Plus or whatever it is. You know, those things, a Basic Plus or whatever. This program is like, you remember when we were kids, we had 2 separate pieces of paper and a checkerboard, more or less, and we number it 1, 2, 3 to 10, and A, B, C, D, G, F, whatever, and then one tells the other, I think you have a ship and G2. They said no, and then or sunk. Well, that's basically what the program is. You tell the thing to go to certain quadrant. So I want to go to Y7 and Z2, and then that machine goes there. So if you have a quadrant, you can make it. It's also in the instruction, you know, the kind of the instruction, the program, or you can download instructions and tutorials and everything. They have it on YouTube. They have them all over the web, you know, tutorials. I read some of the instructions on the manual, and also I watch a couple of those tutorials. Piece of cake, I hope. I don't make a mistake. But the hard part was to set up the machine. I just finished tuning it up, because you had to tell them if you want to do it in metric or you want to do it in inches. If you want to, so you had to tell her how many threads per inch there is on these screws. I choose, for easier calculations, I choose it 3/8/16. That means in each inch I have 16 turns. One turn is 1/16. Easy enough. So 16/16 is 1 inch, because it has 16 turns, and each turn is 1/16. You need 16 turns to go to 1 inch. So I use this so to make it myself a lot easier. Then you have to calculate how many pulses per turn. Normally, there is 200 pulses per turn on these newer motors, the newest stepping motors. So the 200 pulses per turn, so it will move 1 inch. But then you have the servos, which has a half steps, or even more, you know, quarter steps, and so forth, and or 8 steps per step. You can divide it by 8 each step. So you have to multiply the total step times whatever micro steps. That's what the official name is, micro steps. So, but it's not that easy. I hope I did it right. I just finished doing it, and that's the way I understood it so far anyway. I'm brand new at this. I just got this computer 2 days ago, and I just got this. So I never messed around with G-code before. Before, when I show you in the things to come, and in the last video, I had another board. Where is you? Where are you? I was going to say, where is you? Okay, it's called the Stepper P. I don't know what I did with it. Oh, here. It's called this board right here. It's called the Stepper P, and it has a program that is very much intuitive. But with that program that comes with, you can only run one motor at a time. So there I went, spending money for no reason, because in order to make both motors work together, one after the other in the same program, you have to know Visual Basic and all the other baloney. I have no idea, and I don't have no desire to learn that stuff. That's more difficult. So, a lot more difficult. 5 times the difficulty you would have on these. And it's all memorizing and going back to the book and get references. Not for me. I want to have my hands into the game. I already did my schooling days when I was in college. So let's try a run here. I got some pieces of wood before to see how far I was going, but I want to try to do. I'm gonna install a piece of wood, and I'll bring you back. Okay, we unloaded. We put the piece of scrap, and I sandwich it between 2 pieces of MDF. The reason of that is that way I prevent blow up, because it's going to be cutting both ways. They cut one way, it moves. They cut the other way, it moves. They cut the other way, it moves. They cut the other way. That's the way I figured out how to do the finger joint this time. I I'm going to simulate a finger joint. That's all. Okay? Now, I'm going to start the program. The program even starts the router itself. I didn't have it to adjust the height yet, but it can be possible. The only reason is I didn't feel like it was going to be necessary. Now it's coming back to the zero position at home. It's coming back home, but which is x0, y0. So it started in the same place where it's going to end. So that way you don't have to reposition every time. That would just come back to the same place it was before it started. Now, let me move the camera and I'll remove the piece of there. I'm going to remove the lumber out of the scrap out of the. There you go. There is. I think I made a couple of little mistakes in the code, although I did it with a calculator. I think I messed up something in the input, because this one is wider, this one is thinner. So let's see, and that is not what I was set up to do. Yeah. It's not the router bit is just the same size, but the spacing is not correct. But I can fix that up. No problem. I gotta recheck my calculations, and that's it. That's it, folks. Perfect. But one time, there's something went right the first time. Sometimes had to be.
Okay, here's a view of the breakout board and the two drivers for the motors. You can see the wiring is extremely easy. On the instruction that comes with this circuitry, it can't make it any plainer than that. Here is a view for the Mach 3, and it's a free program like I explained before. You load the G code into it and you drive it from here. It is a little bit overwhelming when you first see it, but you get used to really fast to that screen. Here is the motor in the bells and the all thread rod that drives it back, front and back, and as you can see, it's very simple. Here's an expanded view of the whole rod with the motor in front, the bell, and the nut in the back. The nut is got a brass the insert and the anchoring on the back. Here is a view of the drawer slides, the heavy-duty drawer slides that I used. Here's a view from the front. You can see the old thread that drives it from left to right and from right to left, and the carriage where it's mounted. Here's a little different view from the carriage. And here you can see it from the other side with the drive and the pulleys and the motor. So that's basically the whole machine, actually. You can see, you'll see, so the drives and the little timing pulleys. Here's a view from the same left to right shifting from the other side, from the dead end side. And that's all. That's a whole machine. That's very simple. Now,
okay, gentlemen, I see, and perhaps there is a lady over there. Welcome to, ladies and gentlemen. Now you can see that anything is possible. Anything is possible. Thank God that this thing is not that difficult. The wiring on this system is extremely simple. There is just 4 or 5 wires to go from one board to the other, and another 4 wires that go to each motor. So, and then there's 2 more wires that go to a power supply, which I use a power supply that 12 volts that I had. 12 volts, I think it's 5 amps, that I had in the garage for a long time. I don't even know where it came from, but that works. And the breakout board, the power supply is 5 volts, and I take the 5 volts out of my computer USB ports. Simple as that. So that way I don't have to have a second USB. That way I want to show you how the program looks like in the computer. I'm going to take a few stills and we're going to go from there. I'm going to explain. I reiterate, this program is absolutely free from the internet. The free version is for the craftsmen, you know, hobbyists, experimenters, that kind of people, which doesn't use the program for profit, let's say. It's like the Microsoft for students and teachers. Okay, this is a free version for the hobbyist, in other words. The only limitation you have with this is that it's limited to 500 lines of code, which is, for us, for the programming, we're not going to be doing extremely cumbersome pieces of airplanes and parts for motors and stuff like that. We just do straightforward little edges, you know, dovetails, whatever needs to be done on this little machine. I know there is one in the market, but it doesn't do the second. It only moves the fence forward and back. This one moves not only the fence forward and back, but it brings it across the bit, you know, to a certain limitation. Because to cut, I can make it bigger, to cut longer dovetails. But when you're going to cut a longer dovetail than about 18-20 inches, there is no reason. So, and if you have to, you're going to have to make a mark and then move the piece. That's all. But it's even that is not a problem. Thank you very much for watching. I'm going to be posting more as I develop this system. You know, put the bolt down the control panel, the control board. You know, and find a place where I can sit the computer away from the dust and you know, sturdy it up a little bit, because it's a little bit flimsy right now. Well, remember, it's just an experimental machine, so it's a little bit flimsy right now. I had to straighten it up a little bit, but that wouldn't be a major problem either. Okay, thank you very much for watching.